So now we're going to move from Canadian-focused discussion on carbon pricing to more of a global focus. And we've been touching on this over the last day and a bit, but now we're really going to get into the details and hear the very latest updates on microgrids for mines, so microgrids for remote mines. Our first presenter is Daniel Yeager, and Daniel is Manager for Business Development for CrossPower at Pfisterer. Daniel worked as an electrician until 2007 at Pfisterer, Germany, and then he became a project manager for technical sales at a German utility focusing on energy efficiency and renewables projects. Since 2015, he has been Business Development Manager for Pfisterer's CrossPower hybrid energy system, and we're very pleased to have him. Welcome, Daniel.
So, good morning, everybody. My name is Daniel, and thank you for the opportunity to do the presentation here today. First of all, I want to mention I'm not a native speaker, so I'm a German guy, and hopefully you understand what I'm telling. If not, do not hesitate to ask. I will tell you something about our CrossPower system, which is a mobile microgrid system, and it can be easily deployed and removed. But first of all, I want to tell you something about Pfisterer. I think just a few here in the room knew the company Pfisterer. Pfisterer was founded back in 1921 in Stuttgart, Germany. And in the first years, we produced custom-made products for energy utilities for low-voltage products. And today, we're one of the world's largest supplier for cable accessories, system solutions, and cable accessories for power generation, transmission, and distribution. So we are basically coming out of the power distribution and power transmission. As you see here on the map, we are around the world with our businesses. We have currently 2,700 employees and a turnover of more than 400 million euros a year. But why I'm telling you this? Because I want to do the bridge to the microgrids. So as I mentioned, we are coming out of the distribution and transmission grids. So as you see here on the pictures, there are insulators, there are plugs, connectors, whatever you need to do a grid. But then we said, okay, the grid extension in the world is going to be stuck. There's more a focus on decentralized energy production than in grid extension. And so we said, we're in nearly every grid around the world, but what about the people or the industries that are not connected to an energy grid? And that's why in 2015, we decided to invent something or to produce something for these people that are not connected to an energy grid. And so we did our CrossPower system, where I want to go in detail a little bit later. I will now start and go do a little bit of background, but you heard a lot of this yesterday. What is energy production in mines? So if you think about energy production in mines, mines are always on a remote place. So in these areas, in these remote areas, normally the energy is produced by diesel generators or other fossil fuels. For this production, a lot of diesel or other fuel is needed, and also the transportation and the infrastructure to bring the diesel there creates high costs and big efforts. Additionally, the efficiency of the diesel generator of diesel generators under typical load variation is very bad. We heard, as I said, about this yesterday, and also the maintenance of diesel generators creates additional costs. So these were the points we were thinking about and said, okay, what can we do, what can we invent to reduce this? Yeah, we did our cross-power system. Our cross-power system is a hybrid power system, scalable from 25 kilowatt up to 10 megawatt. But our main focus on the system is that it's made for mobile use. So you can deploy it very easily and also remove it very easily to another point. We made containerized solutions. We make a reliable solution with 100% energy supply 24/7. We integrate renewable energies, and we made tailor-made solutions. And we're not tied to single manufacturers. So we want to do a solution which combines different technologies, and we're the system integrator and did the management system by ourselves, and so do a complete turnkey solution for mining or other industry purposes. So yeah, we design every system according to our needs. We use renewable energies that are available, and our goal is to generate at least 50% out of renewable energy, no matter where the system is located. Yeah, we're not tied to single manufacturers, but I will go over this. So I will just go through a little bit fast because I have a case study later, which is, I think, more interesting. Yeah, we have 3 product types. We have the small grid, which is a complete mobile solution up to 50 kilowatt, mostly used for exploration teams or exploration camps. Then we have the medium version, which can go up to 250 kilowatt and can also be completely mobile. This system can be deployed in 8 hours by 6 people without special tools, and you have 25 kilowatt power just in a minute you place it somewhere. And then also the bigger ones, which is a little bit harder to deploy, but also in a short time you can redeploy it and move it to another place. Now I want to come to the case study. We have a current project in Mongolia, so in Asia, for a mine. This mine has 2 options for energy supply where we going into at the moment. So we have the option 1, this is our small system, which is done for the exploration camp. And we have the option 2. This one is the bigger solution for 1 megawatt in this case for the mine. So with our small system, we're currently planning to powering the exploration camp. So we have, as you see in the picture, a complete mobile solution mounted on a trailer. Inside the container, there's a 25 kilowatt hour battery storage and a 25 kilowatt diesel generator. And you have outside these 10 kilowatt peak solar modules, which are mounted on a layer. These are high flexible, very light solar modules, and you can fold it out on the floor and have energy from them very fast. The numbers for this option for this project is we have 25 kilowatt cross power. At the moment they have a diesel generator which runs 6,000 hours a year, and the diesel price there, because it's on a very remote location on 2,900 meters high, we have 3 euros per liter including the transportation. And so we did a comparison between a normal diesel generator and our system, and we say, okay, what we heard yesterday from the colleagues from ABB, for example, they said that we can save up to 50% of diesel. That's what we also said, that's what we can do with our system. And I don't want to go to the numbers in detail. You can read it, you also get the presentation. But I think the interesting thing is that it leads to a return on invest after 2 years. Also due to the fact that the transportation of the diesel there is also creates high costs. The second option that we have there is that we are powering the mine. These are basically 2 mines with 500 kilowatt each. They're located next to each other, and we are going to put one system in the middle of these 2 mines to supply these 2 mines with 500 kilowatt peak each. So the diesel generator in this case also runs these 6,000 hours a year, and the diesel price there is 2 euros per liter, including all transportation and infrastructure costs. So the configuration of the system is we have 1 megawatt peak PV, we have 1 megawatt diesel generator, 1 megawatt hour battery, and our energy management system. Also compared to a normal diesel generator, we can also save 50%, even a little bit more on this, and this also leads to a return on invest of 2 years. But these are projects which are currently in developing. We have one system since 2 years now running with the NATO. It's called the NATO Hybrid Power Generation System, which is currently based in Lithuania in Europe. It will now move to France, and in January it will come to Canada. And the NATO is testing this system all around the world. It was a tender that the NATO specified because they wanted also to do something on renewable energy. And this one is a complete mobile system. We have 25 kilowatt solar PV, completely mobile. We have a 7.5 kilowatt wind turbine with a height of 12.5 meters. We have a battery of 100 kilowatt hours and 2 generators with 75 kilowatt each. So the overall system has 150 kilowatt and can be stored in 2 20-foot containers. So if you want to see also this system in detail, you're invited to come to our stand outside. We have a virtual reality classes there, and you can go through the system with our virtual reality. And how it works, what is the configuration of our system, what is our philosophy. You see here, this is an example of the system from the NATO. This is real data on I need to confess, it was a really, really good day. We had a lot of wind, we had a lot of sun. You see the red one is the load, so it's a typical load for a camp. You have a peak for breakfast, you have a peak for lunch, and you have another peak in the evening for dinner. And as you see, the gray, I don't know how to say, the gray, so the gray pictures here, you see that there's, this is the diesel generator. And in our system, the diesel generator always runs at the maximum point of efficiency and is just charging the battery. So we differ between the generation and the load. So our generation systems, like solar, like wind, like diesel, are just charging the battery, and the battery is supplying the load. With this configuration, we can realize diesel savings between 15 and 20% just by using the battery as a buffering system and running the diesel in a maximum point of efficiency. Additionally, we always leave some space from the diesel. If you see it there, the diesel is charging the battery just 80% full. So we have always 20% left that the renewable energies are able to make the battery full if they come up somehow. Yeah. These are some pictures. As I said, it's complete mobile. You see in the upper picture on the left. So the upper two pictures are one container and the lower two pictures are one container. In the upper container, you see on the left side, there's the battery system with the inverter and with the electronics. And on the back side, so there's a wall in the middle, on the back side, there are the two diesel generators inside. And on the second container, you have the solar container. And in back of the solar container, the wind turbine can be stored. So this system is completely mobile and can be erected or deployed in 8 hours by 6 people without special tools, just by hand. The wind turbine pole is made out of aluminum. It's very light, and you can just pull it up with a rope. The complete system as an overview, it can be housed in two 20-foot containers. It has 150 kilowatt power output, including 25 kilowatt solar PV, two 75 kilowatt diesel generators, 100 kilowatt hours battery, 7.5 kilowatt wind, but we are now adding another wind turbine with 7.5 kilowatt to increase the renewable penetration, and our self-designed energy management system. It's what is very easy, what is very necessary and helpful for the NATO. It's a plug and operate configuration. That's our philosophy. We want to have as much as possible mounted in a container so they can move it with a truck there, just plug it and operate and done. Yeah. And we have latest tests in Lithuania that 39.2% of fuel reducing by using our system. And in Lithuania, it's always not that good weather. We don't have that much sun, so it's not too bad. Yeah. So to summarize, our gross power system can do 25 kilowatt up to 10 megawatt. It's a customized solution. We can make up to 80% saving on fossil fuels on some days. In total, it's 50% over a year. That's what our current data is. And we have a reliability of supply 100%. Yeah, thank you very much.